Hey guys, I'm back with another tips and tricks video, this time for describing data. It's kind of a big topic. I threw a bunch of stuff together in this one because we are dealing with these kind of weekly lessons as opposed to like daily class sessions. So there's a lot going on in this one, so I'm going to go over some of the important things to remember and deal with. So starting with, you may have to draw some graphs. So typically it's going to be like a dot plot or stem and leaf plot, a box plot. You might have to draw some kind of bar graph for categorical data. So just my general hint for that, or tips for that, would be to make sure that you're drawing neatly. Title your graphs always, title your axes, whether it's just the x-axis or the x and the y. Label your axes, and then make sure that your number lines are drawn to scale. So like if you have a distance on your x-axis going from 0 to 100, we want to make sure that each increment is as equal as possible. So like a distance that's 20 shouldn't look visually the same as a distance that's 50, if that makes sense. So I see that a lot, mostly with box plots. When you guys have to draw box plots on things, that's where I usually see a lot of just really extreme laziness to where those distances don't look visually accurate, and that is going to mess up what the box plot or graph should look like. So always draw your graphs to scale. Second thing is when you're describing numerical distribution, so that would be like a histogram, a dot plot, stem and leaf plot, and even box plots, to cuss and BS. That was our trick there. So cuss and BS, C stands for the center. So on a histogram or stem and leaf plot or a box plot, stem and leaf plot or a dot plot, that would be like your peak or your mode in the graph. Where do we see the highest amount or the tallest bars? For a box plot, you're typically going to talk about the median. And then in some situations, maybe not with a graph like that you drew, but maybe just that they have kind of a density curve distribution and they have given you the mean. The mean would be your center. So if you're describing a distribution that you don't necessarily have a graph for, but they did tell you the mean, you would want to say the mean as your center. So some measures of center would be like your mode or peak, your median, your mean. Unusual features is the U, which would be, are there outliers or possible outliers, and are there any gaps or like really low points in the data? Those would be things you'd want to mention. Your shape would be, is it symmetric or is it skewed to the left or to the right, or negatively skewed or positively skewed, or there's a lot of different ways you could say that. You also should mention whether the graph is unimodal. Does it have one peak or mode, or is it bimodal or multimodal where it has multiple peaks or modes? Side note, if you're calling something bimodal or multimodal, you should have listed several peaks or modes when you talked about center. So that's something to keep in mind. And then the other S stands for spread. So that could be as simple as just listing what the lowest and highest values are. You could also say the range. The range would just be the highest minus the lowest. The interquartile range for a box plot is a good measure of spread. Or again, if you're just given information, a standard deviation would be your measure of spread if that was given to you. And then the BS is be specific. So that goes with like context. So make sure you're using words from the problem. But also just make sure you are listing things as specifically as you can and talking as specifically as you can. When you are describing categorical graphs, do not cuss. You still want to be Fs, you still want to be specific, but you are not talking about it in terms of center, shape, spread, and usual features. So you might say like which category has the most or least amount of data. If you're comparing multiple graphs, do they have the same highest, lowest categories? Make sure you're looking at whether your graph is giving you like a number in the frequency on the y-axis or if it's percent, and make sure you're describing that accordingly. So a couple of graphs that I kind of pulled up. This is a lovely graph on number of people and what their nicest fruit is. So we would say maybe the most amount of people chose blueberry as the nicest fruit. And apple is also pretty high up there. The least amount of people said grapes were the nicest fruit, which I'm extremely offended by because grapes are my favorite. Actually, grapes and bananas are my favorites. So this whole graph is very rude to me. So that is kind of a histogram, or categorical, sorry, not histogram, categorical graph and how you might describe it. Another thing I wanted to mention is that you may sometimes be looking at a time plot. So a time plot is something like this, where we are given kind of period of time. So on the bottom, the y-axis would be maybe years or months or something. This is a period of time, and then we're looking at how that data changed over time. So we want to be careful not to try to use cuss and BS or cuss for that. Even if it looks, so this one we probably wouldn't just by natural, but something like this, which is a time plot you may have seen a lot of recently, we might be tempted to call those symmetric or roughly symmetric, but that word or talking about shape in that way is not really appropriate, because technically with a time plot we have two variables. We have time, and then we have the variable that we're studying, which in this case is the number of COVID cases. So a histogram, when we're talking about center, is only dealing with one variable at a time. So this is not something that we would talk about center shape spread unusual features. We would talk about how things change over time. So we would say, like, the very beginning of the outbreak, it was very low, and then it gets higher as we get towards the middle, and then eventually it starts staving off. So just be careful when you're looking at graphs not to call things or not to talk about center shape spread unusual features unless it's a true numerical graph that is dealing with one variable, and then the y-axis is just the number or the frequency for that one variable. So there's that. Then moving on, measures of center and spread. The big thing there is just knowing that for center, like mean versus median, remember that mean can be very misleading if your distribution is skewed. So my example for that, in this situation, we have age of Best Actress Award winners, and that distribution is pretty skewed to the right, has some potential outliers on the upper end of ages. So if I were to find the mean or the average, true average, age of a Best Actress winner, that average is going to be probably higher than you would think, whereas the median is probably going to be closer to the 30s. The mean is going to be upper maybe in the 40s. So what we have to realize is that mean can be misleading if our distribution is not symmetric, if it's skewed. So when I talk about the mean as opposed to the median, that mean is giving me a little bit of a distorted view of what's really true about the majority of the distribution, whereas median is always going to be a lot more true to what the majority of the distribution is dealing with. Same idea with standard deviation and IQR. Standard deviation is very, very affected by outliers and skew. So standard deviation is going to get a lot bigger if we have a lot of skew or outliers, whereas IQR is going to pretty much stay more true to the majority of the data. So if you have a distribution that is skewed, median and IQR are better measures of center and spread, or more accurate, whereas if you have a symmetric distribution, any of those measures are fine, but we typically tend to use mean and standard deviation when a distribution is symmetric, or specifically if it's normal, because then we can use z-scores and all that stuff, which I'll talk about later. When you're drawing a box plot, sometimes you're asked, or a lot of times you're asked, to calculate whether we have outliers. So our outlier rule is we do Q1 minus 1.5 times the IQR. Remember, IQR is just Q3 minus Q1. And then your upper fence would be Q3 plus 1.5 times the IQR. So we're going 1.5 IQRs on each side of the box, part of the box plot. And that gives us our fences. There's a lot of misunderstanding about that when we first learned this. Those fences, which is what I call these two values once you calculate them, those fences are just telling you, like, this is as far as I expect the data to go, so anything outside of that is an outlier. Those fences are not actual data values for the MERP in most cases, so we're not going to necessarily put anything there at those fences on our graph, but they do tell us if we have any data that is outside of these fences, less than the lower end or greater than the upper end. We would call those values outliers, and we would mark that with like an asterisk or a dot or a star, and then the fences would be there, and then you would want to make sure that your tails of your box plot end at the last value in our list that was not an outlier. So you shouldn't be actually marking the fences on your graph anywhere. It is just there as a guideline for us in our minds to know when to start calling something an outlier. If you don't have anything above this upper end or below the lower end, end, there are no outliers. You don't need to do anything different from how you would normally draw a box plot. One of the classwork examples, I kind of go through that with an actual set of data and talk through how we would draw the box plot after that, so make sure you watch that. Sixth thing, scatter plots and linear regression. My biggest hint there is know how to interpret things like slope, y-intercept, r-squared, residuals, correlation. I didn't type in there, but that's another one. Possibly the standard error of the residuals, which is known as SE. For that, my biggest hint, if you don't remember a lot of those, is go find that regression cheat sheet. I did put it on the APStat website under the All the Notes page. Under regression, I did link the regression cheat sheet because I know that that's a big help. So make sure you go back and study those. Obviously, slope and y-intercept are going to be your biggest things that you should know, but r-squared tends to come up quite a lot. And then just the general idea of what a residual is a good idea as well. Part B, how to tell if a linear model is appropriate for a set of data. Look at a graph. You're looking at your original scatter plot to see if it's linear. You're looking at your residual plot to make sure there's no major pattern. There's a classwork problem with that in it, and I kind of talk through that a little bit more in that classwork video. And then talking about describing changes to slope and or correlation if an outlier or an influential point is added or taken away. So when we take away an outlier, something that doesn't fit the data, it tends to make the correlation stronger, and it can affect the slope as well. So kind of being able to visually tell what happens when we kind of move or take away an outlier or influential point. There are some applets I linked them on the APStat website under more. There's a couple different regression applets that are really helpful for kind of helping you visualize how those things affect R or correlation and the slope. So those would be good things to play with if that's something that's harder for you to visualize, if you're not as much of a visual learner. Actually playing with those applets can be helpful. I also put in there know the basic difference between an outlier and an influential point. I doubt this will come up much, if at all, but just know that an influential point basically means that it is influencing the correlation. So taking away or adding it back is going to have a major effect on the correlation. An outlier might be a point that doesn't fit the pattern of the data, but it's not really affecting your correlation all that much. Typically, outliers are kind of above or below the rest of the data, whereas an influential point is to the right or to the left of the rest of the data. Both an outlier and an influential point are not in the pattern, but influential just means that it's having a much bigger effect on your correlation and your slope. And then last but not least, there is a little bit dealing with z-scores and basic normal model. Again, z-scores and normal model are something that is really, we're dealing with it throughout the entire year. It doesn't necessarily fit just within one category. It's something that is really big throughout the entire year. But I did put a little bit of that in this lesson in one of the classwork problems. So just knowing that a z-score is also known as a standardized score and how to find it. So z equals the observed value minus the mean divided by the standard deviation. And knowing that z-score represents the number of standard deviations above the mean. And then knowing your normal model is unimodal and symmetric. The actual normal model, which has an actual equation, is perfectly unimodal and symmetric. And then knowing that you can use your z-table to find probabilities for normal distributions or approximately normal distributions. I did on the APStat website all your tables and formula charts and all that stuff is linked under more. So I mentioned the All the Notes page, which is where you can find just every notes we've done for everything all year, as well as each unit practice and the solutions. And then, like I said, under regression, I added that cheat sheet. Anything that I had a video up on the YouTube channel, I threw a link into that as well. There's like some video playlists and stuff. So definitely check this page out. And then under more, you have things like formula chart, tables, you have these applets down here, so guess the correlation applet and modeling correlations applet, and then there's one called sampling distributions applet. So all of those are really good, helpful things if you want to kind of practice and visualize. So that is all I have for you today for your tips and tricks. Hope you guys are having a good week, and I will see you soon.